Math 1B. Got a new, hopefully short video for you. It's 3.3. We're basically taking a second look at dividing powers. We're going to throw in there zero exponents and negative exponents. So, should be pretty exciting stuff. So yesterday, we learned the third rule of powers, which is if you're dividing them, then a quick way to think about it is just through subtraction. Now, here's a question. Before we try number one, I got a little example I want you to put off to the side. What happens if the bottom is bigger than the top in terms of its exponent? And I want to take two different routes to figure this out. The first route is expansion, where I just multiply it all out. The second route is use the rule. So when you expand, x over x, again, is 1 over 1. X over x, x over x. Okay, what am I left with? I'm left with 1 on top. And on the bottom, I've got x squared. Using the other approach, I'm left with x to the negative 2 power. All right, so now, this gives us an interesting relationship between negative exponents and fractions. What I've shown is that both of these quantities are legitimate algebra values. They both came from these. Same thing. So x to the negative 2 is the same as 1 over x squared. I guess what I'm saying here is that these two are the same thing. Multiplying something by itself negative 2 times doesn't really make any sense, but dividing by something in which you multiply it by itself kind of does make sense. So what I want to do is I want to write all of these answers in terms of positive exponents. So on this whole assignment, only positive exponents. No negatives. No zeros either. So what does that look like? Well, for our first example, I can split this up into the coefficient divided by the coefficient. I can split this up into the w's divided by the w's, the x's divided by the x's, the y's divided by the y's, and then the z's are on bottom, there's nothing else. So I just imply that there's a 1 on top. So 4 divided by 2 is 2. I'm just going to put 2 over 1. W to the 3 over W to the 2, subtract them, you get W to the 1. Now here's the rule I'm going to go with. The bigger power is where the final answer is going to go for a positive exponent. So because the bigger power was on top, W to the 1 remains on top. If you look at x to the 5 divided by x to the 8, the bigger power's on the bottom, so my final answer is going to be on the bottom. 5 minus 8, the difference is going to be 3. Since it's a negative exponent, it's going to go on the bottom part of the fraction. Negative exponents, negative 3, means it's going to be positive on the bottom. The difference between 4 and 12, 8. Bigger powers on the bottom, which means it's going to stay on the bottom. And then z to the 6 was positive on the bottom to begin with. Leave it on the bottom. All right, so I took care of all these. There's a lot to digest right there to start out with. So I understand if you're still a little bit confused about where are my negative exponents. There shouldn't be at the very end. Let's try a fresh example. So let's say you got 7a squared b to the 5th c over 21 a to the 7 b to the 6 c to the 11. So your job is, 1, simplify the coefficient. So 7 divided by 21. The top and the bottom both divide 7. That simplifies to 1/3. So I get a fraction with a 1 on top and a 3 on the bottom. Hopefully that makes sense. 2. Subtract exponents of powers of the same base. Of powers with same base. So these two have the same base. A to the 2 and a to the 7. The difference between the two is 5. Since the bigger one's on the bottom, I'm going to leave it on the bottom and keep it positive. If we're still a little confused by that, check this out. A squared over a to the 7 is equal to a to the 2 minus 7, which is a to the negative 5. Right, it's a negative exponent. But a squared over a to the 7 is a times a over 1, 2, 3, 4, 5, 6, 7. It's 1, 2, 3, 4, 5 positive a's on the bottom. I'm just saying, hey, if the bigger number's on the bottom, that's what's going to happen. So then b to the 5 over b to the 6, subtract the 2, the difference is 1, the bigger one's on the bottom, so it stays on the bottom with a positive exponent. All right, c to the 1 on top, 1 minus 11 is negative 10, or think about it as it's going to be c to the 10 on the bottom. All right, now this one's a little bit tricky. We have negative exponents at the very beginning of the problem. We can fix that very easily. If it's a negative exponent, it's in the wrong part of the fraction. If it's a negative exponent, moving it to the opposite part of the fraction makes it positive. It's like we've got this rule now. X to the negative b power equals 1 over x to the b. That's something that I showed in the first example. Can you guys see that? Okay. Also, if it's 1 over x to the negative c, that's the same as x to the positive c in the top part of the fraction. So negative exponents are basically just, they're not written correctly. They're not in the spots that they're supposed to be, in which we can read them as positive exponents. So here's what you're going to do first. Step 1, move the negative exponents. So moving day for you, moving day for you, moving day for you. Everybody else stays where they are. So w to the 4 stays where it's at. X to the 6, y to the 4, z to the 9, they stay. Z to the 15 stays. But your w to the negative 5 is going to be w to the positive 5 on the bottom. X to the negative 8 is going to be x to the positive 8 on top. Y to the negative 5 on the bottom is going to be y to the positive 5 on top. So, now that everybody's a positive exponent, it's easier for us to visualize hey, you guys are on the same side here. You're multiplying. What's the rule for multiplying? Add the exponents. You're going to get x to the 14 on top. Look at these y's. They're also on top, so you're going to multiply those. Y to the 4 times y to the 5 equals 4 plus 5 for the y value. That's going to be y to the 9. The w to the 4 times w to the 5, that's going to be w to the 9 on the bottom. And then z to the 9 over z to the 15, they're in separate parts of the fraction, so subtraction is what we want. The bigger of the two is in the bottom, so our answer is going to be z to the 6 on the bottom. All right, here's the last one. We have a 0 exponent, which we actually saw in the last video. On the last video, you guys had to deal with x to the 6 divided by x to the 6. Now, technically, we talked about how anything divided by itself is 1. And that's certainly true. If I expanded x to the 6 over x to the 6, there'd be 6 x's on top and 6 x's on the bottom. You get 1 over 1 6 times. And it equals 1. But if you use the rules of division, subtract. 6 minus 6 is 0. Whoa! We just showed that x to the 0 power is the same as 1. Which is basically the rule. Anything to the 0 power equals 1. So then, replace p to the 0 with 1. If you're a negative exponent, move to the opposite part of the fraction. Become positive. So you're going to move, you're going to move, you're going to move, and you're going to move. I'm not going to move the negative 8 because it's a coefficient, not an exponent. Negative 8 stays. In fact, what is negative 8 divided by 12? It's negative 2/3 because the top divides 4 and the bottom divides 4. So h squared stays. P to the 0 becomes 1. H to the 8 stays. K to the 7 stays. You're going to move g to the negative 5 down, and it becomes g to the positive 5. G to the negative 7 moves up, which is g to the 7. K to the negative 5 becomes k to the positive 5 on the bottom. M to the negative 4 on the bottom becomes m to the 4 on top. So the negative 2 times 1 is just negative 2. That 1 kind of just disappears. G to the 7 over g to the 5, that 3 stays the same, is going to be bigger 1 on top. 7 minus 5 is 2. H to the 2 over h to the 8. The difference between 2 and 8 is 6. Bigger 1 on bottom, answer on bottom. K to the 5 times k to the 7, both on the bottom, you're multiplying them, which means add the exponents. It's going to be k to the 12 on the bottom. And then m to the 4, all by its lonesome, positive on top, stay on top. All right, now guys, this certainly was a video that should supplement what I talk about in class. Negative exponents can be very, very tricky, so I'm banking on this is just after you get an in-person lesson to really make things solid in your minds. Okay, so be patient with it. Thank you for watching the full video, and yeah, that's all I got.